So, you've probably heard of these things in the sky or in space called black holes. There are these mysterious objects in the sky that don't let anything escape, not even light. But why is that? Why don't they let anything escape? And how do they appear? Well, you see, a black hole comes from a star that's more than 10 times the size of our sun. So when a star that's more than 10 times the size of our sun dies, then it collapses and forms a black hole. But you might be wondering, how does a star die? I thought stars lived on forever, right? Well, you see, stars are very big and they have lots of mass, which means that it's so big and has so much mass that all of this stuff on the outside is always constantly trying to push in and crush the stuff on the inside. And, well, the stuff on the inside, what's on the inside of a star? Well, usually the inside of a star has lots of hydrogen atoms, like these H's. Now, normally they're just bouncing around, like bounce and then bounce away. But then because all of this stuff on the outside is pushing in, it forces the hydrogen atoms so close together that eventually they get crushed together. So two hydrogen atoms get crushed together, and then what do they form? Well, they form a helium atom. And you see, when it forms this helium atom, it releases lots of energy. And this energy pushes back out against the force from the outside. So then, this way, the star is balanced. So the stuff on the outside pushing in is balanced from the stuff on the inside pushing out. So this goes on for lots of years, in billions of years in fact, the hydrogen atoms getting crushed together to form helium atoms. But soon, because a star doesn't have infinite hydrogen atoms, soon there will be no more hydrogen atoms to crush together. And now there's all that will be left are helium atoms. And because helium atoms are much harder to crush together, then the star can't manage to crush all these helium atoms together, which means that now this star will slowly be being crushed inwards and inwards and inwards. But because when it's being crushed, the helium atoms are also being forced together. And soon they'll get so tight that the helium atoms will combine once again, just like how the hydrogen atoms combined. And this time they won't form helium, they'll form carbon, which is an even bigger atom. And because this is even harder to do, it releases much more energy, which means that this star will expand to much larger than it used to be, which means that it'll expand all the way, almost maybe even twice as big. And then this is when we call something like a star this big, we call it a red giant. And if our sun becomes a red giant, it'll swallow both Mercury and Venus. And it might even swallow Earth. But don't worry, that won't happen for tens of hundreds of billion years. So when it becomes a red giant, the helium atoms are just crushing and crushing and crushing together. But again, soon there won't be any helium atoms left. And soon there'll only be carbon atoms left. And because carbon atoms, it's much harder, even harder to crush these two together. So the star cannot do this. It can't do it. So once again, the outside stuff is going to be pushing in, and again, forcing it even smaller. But now, because the force still isn't strong enough to form these carbon atoms together, it'll all crush into a tiny little star, about the size of our Earth, but much more dense. And this star is called a white dwarf. And these white dwarfs can last hundreds of billions of years. until they finally cool down from all that energy of being crushed together and form a black dwarf. Now, this universe isn't old enough for any black dwarf to exist. But who knows? Maybe sometime we'll discover one. But this is what happens to a star that's up to 8 times the size of our sun. That's still pretty big. But what about those stars that are 10 times the size of our sun, right? What happens to them? Well, you see, stars that big, they're still stars, which means that they'll still crush hydrogen atoms together to form helium, and they'll still turn into a red giant. But this time, instead of forming a white dwarf, they will do something a little bit different. You see, because it's much bigger, which means that there's much more force crushing on the outside. Which means that when there's finally no more helium in the inside and no more energy produced, well, that means that it'll be crushed together much quicker. Which means that all of this outside stuff will crush all the stuff inside into a tiny little point. And this, we call it a singularity. And this is how a black hole is born. Now, because this forms so much energy, it'll release so much power that all of this stuff on the outside will be exploded off into space in a gigantic supernova. But why? Okay, so that's how a black hole is born, but why doesn't it let anything escape? Well, you see, Einstein, he was a famous physicist. He came up with this theory called general relativity. And in general relativity, it basically says that space isn't just space. It actually is made up of something called space-time. And this is basically saying that space and time are linked together. So if you think of space-time as something like a trampoline or a tight blanket, it's usually flat, right? But then if you sit on it, or if we put something on it, then it bends a little bit, like this. And this is the same as space, even though you can't see the bend. So if you put something like the Earth here, then the Earth causes this bend. And this bend is actually gravity. Because, you see, if you put maybe something like a marble on this trampoline, it'll roll towards this Earth, like it's attracted to it. And that's the same as gravity. Things are attracted to bigger things. Well, and for something as dense as a singularity in such a small point, it actually makes a huge indent in space-time, like this. And the singularity could be all the way at the bottom right here. But, okay, so even though it makes this big indent, couldn't something go super fast and just zoom out? Well, you see, because space-time, or general relativity, says that space and time are like connected, it basically says that if you bend space, you bend time just a little bit. But for something as dense as a singularity, it bends space so much and time so much that it bends it in a really weird way. So after the point where it bends it so much, it basically bends time downwards. And this point where it bends time downwards is called the event horizon, which is basically like the point of no return. After you pass it, you can't go back. Now, the event horizon is where time gets bent so much it goes down, which is saying that if you cross the event horizon, the only direction that you go to go forwards in time is towards the singularity, because that's the direction that time is going. So basically, if you want to go back across the event horizon and escape, like this, then you actually have to go backwards in time. And even if you could do that, the laws of physics say that once you go back in time, you eventually have to return to where you went back in time, so you don't create a paradox. Which is basically saying that if you escape this black hole, eventually you have to go back into the black hole, so you don't make a paradox and do whatever that does. Who knows? So that's basically why you can't really escape a black hole, because it bends time and space so much that that to escape it, you really actually have to break the laws of physics, which you can't do.